All right, so now we're looking at the next step of differential equations, which is to verify that a solution is in fact a solution to a differential equation. So let's look at this example. It says verify that y equals the square root of 2x plus c is a solution to the differential equation dy dx equals 1 on y, and hence find the particular solution given that y of 1 equals 9. All right, this notation might be new to you, but basically this is like function notation. It's saying that y is equal to 9 if x is 1. So similar to function notation, but since we're not using function notation in this question, we have to introduce this idea of just saying y of 1 equals 9. And that'll come in handy when we need to find the particular solution. Okay, so let's see if we can make some sense of this. We can see that the left-hand side of this equation is dy dx. So we need to find dy dx. We need to find the derivative of this. Now, hopefully you're recognizing that in order to find the derivative of this, we need to use the chain rule. So let's set up the chain rule. So we're going to say that y equals 2x plus c all to the power of 1/2. Now, remember that when you take the square root of something, it's the same thing as raising it to the 1/2. Now, let's set the inner function and call that u to be 2x plus c. dy du then, so the derivative of this with respect to u, so basically y is u to the power of 1/2, is you take a half down, u to the power of negative 1/2, because we decrease the power by 1. 1/2 minus 1 gives us negative a half. And so we also get du dx, the derivative of the inner function is just 2. Okay, and the chain rule says to find dy dx, multiply dy du by du dx. So we get this. This 1/2 and this 2 are going to cancel out. So we're just left with u to the power of 1/2. Excuse me, u to the power of negative 1/2. And when we have u to the power of negative 1/2, that's the same thing as 1 over u to the power of a half, or 1 over the square root of u. And so we get 1 over the square root of 2x plus c. So dy dx, the derivative of this thing is 1 over the square root of 2x plus c. The next thing we need to do is show that this verifies the equation and that it equals the right-hand side, which is 1 over y. Well, hopefully that's pretty straightforward. 1 over y is just 1 over the square root of 2x plus c. So we can see that the left-hand side equals the right-hand side. So y equals the square root of 2x plus c is a solution to the differential equation dy dx equals 1 on y. So we sort of verified that it is in fact a solution. Okay, now we need to use this next piece of information to find a particular solution. So given that when x is 1, y is 9, find basically the value of c. So let's do that. We know that y equals the square root of 2x plus c. We know that when x is 1, y is 9. So sub that in and find c. We're going to square both sides. 9 squared is 81. And so 81 equals 2x plus c. So c equals 79. And therefore y equals the square root of 2x plus 79 is our particular solution given this information. All right, what I want to do now is look at the graph of these two things. So let's come over here and have a look at that. We can see in green, we've got y equals the square root of 2x plus 79. And in red, we've got the derivative, which we said is 1 over the square root of 2x plus 79. Okay, let's just look at this first part to understand what's going on. We're thinking about the derivative of the green line. You can hopefully see that the green line, if you were to draw tangents, in fact, I can show you the tangents. If you were to draw tangents really close to its endpoint there, you're going to get almost vertical tangents, which is why the derivative asymptotes along negative 39.5. So basically, these m values are getting really large. So your derivative values explode. Remember, the red line is just graphing the derivative values. So it's graphing the gradient of the green line. So as we see, as we move away from the endpoint, the gradient gets smaller and smaller. And so the red line gets smaller and smaller, or gets closer to 0. Now, what I want to show you now is just what happens as this point moves further to the right. So just give me 1 second. All right, so now let's look what happens as this dot moves further to the right. Hopefully you can see that the gradient will be decreasing. The gradient of the green line is decreasing as we move to the right. So you can see these values here, the gradient values are getting smaller and smaller. And so that's what the red line is graphing. It's the y values of the red line, right? And so it gets smaller and smaller and it approaches zero because it's getting flatter and flatter as it travels along. Okay, so hopefully you can sort of see visually why the red line is the derivative of the green line. And hence it verifies our solution to the ordinary, to the differential equation that we had before. All right, try this problem out and let me know how you go. So verify that y equals x log base e of mod x minus x plus c is a solution to the differential equation dy dx equals log e of mod x. Hence, find the particular solution given that y of 1 equals 3. Give that a go and feel free to let me know how you go. Good luck.